Okay, so now that we've kind of made our list of different Laplace transforms, what happens when we apply the operation on them, if we do the inverse Laplace transform, what we get, right? Now let's actually do some examples. So I'm going to give you some functions, right? In this case, I'll call it f of t. Let's say that equals t to the fifth power. Okay, that means the Laplace transform of f of t, so the Laplace transform of t to the fifth, what's that going to equal? Well, if we go back to our table up here, right, the Laplace transform of t to the n is n factorial over s to the n plus 1. So this is going to be 5 factorial over s to the 5 plus 1, so s to the sixth, right? And remember, 5 factorial, that's just equal to 120, so this is just 120 over s to the sixth. So if we have our f of t, apply the Laplace transform, we're going to get 120 over s to the sixth. And it's nice to not have it in terms of like a, b, lambda, you know, all these constants. So we have actual numbers there. Our only variable is s. Okay, let's say we have another one. Let's say we're taking the, let's say we're doing, I'm just going to write capital F of s here. Let's say we're taking our function f of t, right, our new function. Let's say that equals sine of 4t. And the test question was, find the Laplace transform of f of t. Right, well, remember, we have our sine Laplace transform. So the Laplace transform of sine of 4t, right, that's the sine of bt, where b is just 4. Okay, so remember, this is going to be b over s squared plus b squared. So if we use this, right, b is 4, right, so b over s squared plus b squared, which is 16, right, and this is going to be our capital F of s. And notice how we could also use this inverse property. So we could have done 1 over b, right? But I think this way is a bit easier because we know b is just 4, so it's going to be b and then b squared, right? S stays the way it is. That would be that example there. Okay, let's say we're trying to apply the Laplace transform on 4e to 3t minus t squared. So these are all just like, you know, random functions, right, that I'm just coming up with literally on the fly. But this is an exponential minus a polynomial. Remember, this is the same as the Laplace transform of e to the 3t minus the Laplace transform of t squared. So I'm going to break this up. I'm going to go this minus the Laplace transform t squared. So remember, this is also, this 4 here, we can also factor this out because remember up top here, I said if we had a c in front, we could factor that c out, so we could go c times the Laplace transform, right? This is going to be equal to 4 times the Laplace transform of e to the 3t, right? So if the Laplace transform of e to the lambda t, right, was equal to 1 over lambda, s minus lambda. Lambda in this case is 3, so it's going to be 1 over s minus 3. So 4 times 1 over s minus 3, that's 4 over s minus 3. Right? And so, just looking this over here. S minus 3. Yeah, so, and then we're going to go minus, if we have t squared, right, we're subtracting the Laplace transform of t squared. We just go to the t to the n column here, or the t to the n row, and we see that it's going to be 2 factorial, right, because it's t squared, so 2 factorial over s to the 3. So 2 factorial is just 2, so 2 over s to the third power there. That'd be the answer for that example, and this would equal your capital F of s. Okay, kind of cool. So now, let's do another one. Let's just do maybe one more. Let's say f of t was equal to t minus 8. T minus 8 plus cosine of I don't know, 2t. Okay, well, the Laplace transform of f of t, right? Like I said before, we can just break all these up. So this is going to be 1 factorial, like for the t part, it's going to be t to the 1, so 1 factorial over s to the 1 plus 1, so it's going to be 1 over s squared, right? And this 8 here, we can think of this as minus 8 times the Laplace transform of 1. So we can just factor an 8 out of 1. It's essentially going to be 8 times the Laplace transform of 1. The Laplace transform of 1 is 1 over s, so it's going to be minus 8 over s, right? And then we're going to get plus cosine 2t. Remember, with cosine in our kind of table here, cosine of bt is s over s squared plus b squared. So remember, the 2 is going to replace the b, so it's going to be s over s squared plus 4. Okay, and that's going to be our answer there. So in my next video, I'm going to talk about examples with inverse Laplace transforms doing the same thing. So I'll see you there.